Okay, hello. This is calculus 2, right? And we're dealing with typically just the integration techniques. Okay, so for number one, right, they want us to evaluate or solve this integral, the natural log of 1 plus x dx. Okay, so trying to solve this particular problem, first of all, we have what we know as a definite integral. Okay, it's definite because it has boundaries. Okay, it's not infinite. Okay, so our first step, really, in this solution, we're going to use two different types of integration techniques. Okay, one's going to be substitution, the other one's going to be integration by parts. Okay, um, so for the substitution part, I'm just going to rewrite this. Substitution by parts. Okay, I'm just going to write this as, I'm going to say let my s, instead of me using u, because I'm going to use I'm going to use substitution by parts and integration by parts. So I want to use letters that are not common what we normally use. Okay, equals 1 plus x. Okay, and if I take the derivative of that, which is ds, it's going to be dx. Okay, now I'm going to take that component, right, and I am going to just rewrite this. Now it's going to look something of this nature. R0 to 1, the natural log of 1 plus x dx is the same thing as 0 to 1, the natural log of s ds. Okay, I just rewrote it, just using substitution by parts. Okay, now I want to go move further and evaluate this. Right, I'm going to evaluate this from 0 to 1, the natural log of s ds, and I'm going to use integration by parts. Okay, and that tells you and I the integrated formula for integration by parts is going to be u dv equals uv minus v du. Okay, now I'm going to say let my dv, as we've been discussing, dv happen to be ds. Okay, this part right here. And I'm going to say, if I take the integral of that, I'm going to get s. Okay, now I'm going to say my u is going to be the natural log, right? The natural log of s. And my du, talking about this now, my du now is going to be 1 over s ds. Okay? Now, with that being said, I'm going to move further and now use my equation here. So if I have this from 0 to 1, my natural log of 1 plus x dx equals, okay, now this is my first part, the UVS, the UV, the U happens to be, U happens to be the natural log of S times my V, which is S, this is my V right here, equal but minus the integral of V du, my V happens to be S times du 1 over S ds. Okay, I'm going to take this step further, right? And I'm going to say s times the natural log of s. I just brought this s over here. I'll just rearrange that. Minus, we know that this s cancels out this s, so now I'm left with ds. Okay? Now, I can take this a step further and say now s times the natural log of s minus s. Okay? So you can safely say that integral of 0 to 1, the natural log of 1 plus x dx equals this. Now I'm going to go back and substitute what my s was. Our s in the beginning was 1 plus x, and our ds was dx. Okay? So if I do that, now I'm going to get 1 plus x, the natural log of 1 plus x, right, minus 1 plus x. Okay? So again, the integral of 0 to 1, the natural log of 1 plus x dx equals this. Okay? But we have a definite integral. Okay, so now I'm going to integrate. Wherever I see, I'm going from 0 to 1, so it's going to look something like this nature. Okay, so from 0 to 1. The natural log of 1 plus x dx equals, wherever I see x, I'm going to put a 1. 1 plus 1, okay, times the natural log of 1 plus 1 minus 1 plus 1 minus, let me just bring this over so we can see this here. Okay, minus, just going to do this zero part. Okay, and that's going to be 1 plus 0 times the natural log of of 0, right, minus 1 plus 0. Okay, so this gives us 2 times the natural log of 2 minus 2 minus the natural log of 0 minus 1. Okay, and then when we go and substitute now, so we put this in our calculator, we should get here we should get negative 0.613705, right, minus 1. Okay, this turns into a plus, negative 0.613705 plus 1 equals 0.3862. And this typically is your answer. Okay, I hope this helps. Kindly let me know. Thank you very much. I appreciate you. Thank you. Bye-bye.